In this video, I'll be going over examples 22 through 25 on the half blue sheets of paper. Let's start with number 22. In the following diagram, the measure of angle ABD equals x squared, and the measure of angle DBC equals 6x. Solve for x. So the first thing hopefully you did is you labeled the measure of angle ABD as x squared and the measure of angle DBC as 6x. What you notice on the diagram based on the tick marks is that those two angles are congruent. The hint actually tells you that an angle bisector creates two congruent angles. So that's the scenario that we're seeing in this example. So because those tick marks indicate that those angles are congruent, we know that x squared must equal 6x. So the way that we solve this example, because there are x's on both sides of the equation, one of them is an x squared and one of them is an x to the first power, they're not combinable. So what we need to do is move all of our terms over to one side of the equal sign. So I'm going to go ahead and subtract 6x from both sides. What happens on the right side of the equation is we get equals 0. That's what we want so that this equation will be factorable. Okay, when I go to subtract x squared minus 6x on the left side, I find that those terms are not combinable, so I just need to rewrite that expression, x squared minus 6x. At this point, we need to factor. So the way we factor x squared minus 6x is we're going to find a GCF. So factor out the GCF. The x squared and the minus 6x have an x in common. So the x is my GCF. That will be followed by one set of parentheses, and I'm going to bring down my equals 0. I need to figure out what's left inside those parentheses. So I'm going to take each term and divide by the GCF to figure out what's in parentheses. X squared divided by x is x. Negative 6x divided by x is negative 6. So I end up with an x minus 6 in parentheses. At this point, I'm ready to actually find my solutions for x. I know that in order for x times x minus 6 to equal 0, I have two choices. Either x equals 0 or x minus 6 equals 0. X equals 0 ends up being one of the solutions that satisfies my original equation from the beginning. However, it doesn't actually work given this geometry scenario. If I were to plug 0 back in for the measure of angle ABD, I would get 0 squared, which is 0. In this scenario, we do not have angle measures that are 0 degrees, so this doesn't make sense. The reason we're getting it as a solution is because if I plug in 0 for the measure of angle DBC, 6 times 0 is 0, these are equal. These angles are equal. It is a solution that satisfies the equation. However, since it doesn't work in this scenario, we have to reject it. Meaning our other solution, when I add 6 to both sides here, I get a solution of x equals 6. That must be the solution that works for this scenario. So my check is going to be to find the measure of angle ABD. Okay, x squared would be 6 squared, which is 36 degrees for the measure of angle ABD. And I want to make sure that that is the same measurement as angle DBC, 6x. So 6 times 6 is 36 degrees. So our solution checks, and we find that our answer to the question must be this answer that I've circled here, x equals 6. Let's take a look at example 23. In the following diagram, AC equals x squared and AB equals 6 minus 2x. Solve for x. So the first thing I'm going to do is label my diagram. AC is this entire line segment. I know that it is x squared units in length. We continue labeling our diagram with line segment AB being 6 minus 2x units long. In this scenario, we are being shown by the tick marks that B is the midpoint of line segment AC. We know a midpoint divides a line segment into two congruent parts. So if line segment AB was 6 minus 2x, I also know that line segment BC is 6 minus 2x. The hint in this question tells us that part plus part equals whole. So what I know is that if I add part plus part, it will equal the whole line segment. The equation that I come up with then is 6 minus 2x plus 6 minus 2x equals x squared. I proceed through my algebra by combining like terms. My negative 2x and negative 2x combine to give me negative 4x. Positive 6 plus 6 gives me a positive 12. I'm going to bring down my equal sign, and I'm going to bring down my x squared. Because I have x's on both sides of the equal sign, where one of them is an x squared and one of them is an x to the first power, I know that this equation will require factoring. So what I know I have to do is move all of my terms over to one side of the equal sign. I'm going to begin by adding 4x to both sides, because what that's going to allow me to do is move the 4x term over to the side where the positive x squared already is located. Then I need to move the 12 over to the right side as well through subtraction. 0 equals x squared plus 4x minus 12. None of those terms are combinable, so I need to leave it as is. This trinomial can now be factored. I'm going to make sure that I rewrite my 0 and rewrite my equal sign. And I know that this trinomial needs to get factored into two binomials, which include two numbers that multiply to negative 12. And the two numbers also need to add to positive 4. So with a little bit of investigating, I figure out that I need a positive 6 and a negative 2 for my two numbers. At this point, I know that there are two solutions, either x plus 6 equals 0 or x minus 2 equals 0. When I solve those quick linear equations, I know I get my two solutions, add 2, x equals positive 2, as well as x equals negative 6. We do have to be cognizant of the fact that one of these answers might need to be rejected. So we do need to make sure that we do a little bit more exploring. The first possible solution that I'm going to check is x equals negative 6. So I need to plug negative 6 in for x. Negative 6 squared is positive 36. And I also need to plug in x equals negative 6 into the other expression. 6 minus 2 times negative 6 is 18. What we want to make sure that we're seeing here is that these numbers are not the same. They're not supposed to be the same. Remember, the line segment AB is supposed to be half the length of AC. So we find that we have a solution that works. X equals negative 6 does indeed work. So that is one solution. The other solution, x equals 2, might work, but it also might need to be rejected. We have to explore a little bit. So let's plug x equals 2 in for x squared. 2 squared is 4. And let's also plug in x equals 2 into the other expression, 6 minus 2x, which in this case will be 6 minus 2 times 2, which is 2. Again, we're supposed to see a relationship here where AC is twice the length of AB. In other words, AB is half the length of AC. That is what we're finding here. So for this example, we actually have two solutions that work. X can equal both negative 6 and 2. Let's take a look at example 24. In example 24, we're told that in the following diagram, the measure of angle ABC equals x squared minus 12x, and the measure of angle CBD equals 4x. Solve for x. So let's go ahead and label. Angle ABC is x squared minus 12x. Angle CBD is 4x. The hint here states that a linear pair sums to 180 degrees. That's exactly the scenario that we're seeing in this diagram. these two angles are supplementary. They will sum to 180 degrees. So when I go to set up my equation, I'm going to state that x squared minus 12x, one of my angles, plus 4x, the other angle, must equal 180. The first thing I notice is that there are like terms on the left side of this equation. So negative 12x plus 4x can be combined to give me minus 8x, bring down my equals 180. At this point, I am recognizing that this equation will require factoring, so I have to move the 180 over to the left side through subtraction and get my equation set equal to 0. Over on the left side, I have x squared minus 8x minus 180. None of those terms can be combined. Once I get that trinomial, I now need to factor. So I'm looking for two numbers that multiply to negative 180 that also add to negative 8. With a little bit of investigating, I can figure out that the two numbers I'm looking for are negative 18 and positive 10. That allows me to find my two possible solutions. Either x equals positive 18 or x equals negative 10. Or we may find that both work. In order to determine whether they both work or only one of them works or neither of them work, we have to do some checking. So first, let's check x equals 18. The measure of angle ABC equals x squared minus 12x. When I plug 18 in for x, I get 18 squared minus 12 times 18. I get 108 degrees. The measure of angle CBD is 4x. When I plug 18 in for x, I get 4 times 18, which is 72 degrees. The relationship that we're supposed to be seeing here is that they're supplementary. So the check is, does 108 degrees plus 72 degrees really equal 180? And it does. So x equals 18 is one of our solutions, maybe our only solution. We also need to check x equals negative 10. The measure of angle ABC is x squared minus 12x. When I plug negative 10 in, negative 10 squared is 100 minus 12 times negative 10. That's actually going to be 100 plus 120, which gives me 220 degrees. What I find is that that solution is not consistent with the diagram that's in front of me. That number itself is already bigger than 180 degrees, so we'll have to reject x equals negative 10 and say that there is indeed only one solution, and it's x equals 18. For our last example, number 25, it says in the following diagram, the measure of angle DAB equals x squared plus 7x, and measure of angle CAE equals x squared plus 10x minus 27. And we're asked to solve for x. When I label my diagram, I find that these two angles are vertical angles. Since I know that vertical angles are congruent, I know that I can set x squared plus 7x equal to the other angle, x squared plus 10x minus 27. I notice that I have an x squared on the left side of my equation and an x squared on the right side of my equation. So when I go to subtract the x squared from both sides, I find that that term actually disappears from both sides. I now have an equation that does not require factoring. This equation, all that needs to be done is get the like terms together. So I'm going to subtract 10x from both sides, and I'm going to get negative 3x equals negative 27. Get the x alone, so divide both sides by negative 3, and I find that x equals 9. There's only one possible solution because this equation ended up not being a quadratic. It did not have an x squared. So one possible solution. We do, however, have to check to make sure that it works. So let's check x equals negative 9 real quick. When I plug it back into the measure of angle DAB, I find that I get an angle of 144 degrees, and measure of angle CAE, also 144. It checks, so it's our answer.